In our last lesson, we learned about the control chain, which is made up of the input element, signal processing element, final control element, and the output element. Examples of input element will be the sensor, switches, buttons. Signal processing element, which is the brain of the system, can be the computer, microcontroller, programmable logic controller, which you will learn later on. Final control element will be the directional control valve, the motor contactors. Output element can be the cylinders, the motors, the lights, and etc. We also learn about the different types of cylinder, the single and double acting cylinder, the different type of directional control valve, 3-2-way normally closed direction control valve, 4-2-way directional control valve, and etc. And how we use the directional control valve to change the direction of the cylinder to make it extend or retract. We also learned in our EP1 lab sheet about pneumatic memory and electrical memory. In fact, they ask you whether the double solenoid directional control valve is using pneumatic memory or electrical memory. So, let's first go through pneumatic memory. A circuit using a double solenoid directional valve is said to have pneumatic memory. Okay, what is pneumatic memory? Pneumatic memory means that it has good memory. It can remember its last position. Okay, so let's take a look at this example over here. For instance, to make the cylinder extend, I will energize the first solenoid momentarily. Okay, in layman terms, it means that you give it power for maybe 2 seconds. Okay, the moment you do that, you will activate this box and it will stay there. Okay, so the air will just go into the ball end of the cylinder to make this cylinder extend. So you can see that the moment you energize this first solenoid momentarily, it will just stay there extended. Okay, so how do I make this cylinder retract? In order to make this cylinder retract, all you need to do is to apply the same concept by energizing the second solenoid momentarily, so that you activate this box over here and it will make the cylinder retract, as you can trace the air flow path here. Okay, so the key word here is momentarily, and it means that you just need to give it a pulse signal, meaning in layman terms, as I emphasize again, it means that you just need to power on for maybe 2 seconds on the respective solenoid to make it extend or retract. Okay, so pneumatic memory means that you can remember its last position, and double solenoid directional control valve is said to have pneumatic memory. Okay, so how about electrical memory? Electrical memory is actually a circuit using single solenoid spring return valve, and it needs to have its electrical signal stored there, and hence is said to have electrical memory. Okay, what does it mean? Okay, so basically, in order to make this cylinder extend, I need to constantly energize this solenoid. Okay, the keyword here is constantly turn on this solenoid. Okay, the moment you switch off the signal at the first solenoid, okay, what happens is it will go back to its spring position and it will make the cylinder retract, as you can trace the air flow path here. Okay, so single solenoid directional control valve is said to have electrical memory because it doesn't remember its last position. Hence, you need to constantly turn on the solenoid in order to make it extend in this example over here. So with this concept, you know what is pneumatic memory, what is electrical memory, and a double solenoid directional control valve will have pneumatic memory, while a single solenoid directional control valve will have electrical memory. Okay, so with this, I will move on to EP2 worksheet again, and this time around we will touch on flow control valve. For flow control valve, sometimes we call it throttle check valve or throttle relief valve. Okay, as the name suggests, flow control means that you are actually trying to control the flow of a medium, which in this application is the air. So by regulating the flow of the air going into the cylinder, we can control the speed of the cylinder. So the flow control valve is actually used to control the speed of the cylinder, and there are 2 methods of flow control. One is called supply air throttling, and another one is called exhaust air throttling. Okay, we will touch on these two methods in the subsequent pages, okay, and explain to you how it works and when to apply the appropriate flow control. Okay, so now let's take a look at the flow control symbol. This is the cross-sectional area of the flow control valve. Okay, it has a knob over here to allow you to adjust the amount of air going through, and this is the check valve. Okay, so when air is coming in from the left, okay, you can see that the check valve will actually block the air. Okay, however, you can adjust the air going through using this knob over here. In other words, you are able to regulate the amount of air going through. Okay, however, look at the next scenario where the air is coming in from the right. Okay, you can see that this check valve over here allows free flow of air going through. Okay, it means that you can't throttle in this scenario because it allows free flow of air going through. Okay, now let's further illustrate this concept using the flow control symbol. Okay, this is the flow control valve symbol. Look at this arrow over here. Okay, it means that you can actually adjust the amount of throttle, okay, the amount of air going through. So as long as air can go through this path, it means that you are able to control the amount of air. Okay, this is a check valve. It either blocks or it allows free flow of air going through. Okay, so let me draw this out first to illustrate to you how this check valve works. Okay, so this is the check valve. Okay, this is just an illustration. Okay, this is the ball. Okay, so can you imagine that when air comes from this direction, okay, the check valve will actually block the air. So in this case, if the air comes in here, okay, let's draw the path. It will actually block. Okay, so the air has no choice but to go through this throttled path. So this is called throttled flow. Okay, and maybe I will just indicate here block. Okay, so next let's look at the other one. Okay, same thing, check valve. Okay, but the air is coming in from right. Okay, can you see that it will not block the airflow? It will allow free flow. Okay, so let's draw the direction of the air. Okay, so it will go through this check valve. Okay, without the need of going through the throttle valve, because the check valve allows free flow of air. So this is free flow. Okay, so now we will proceed to the next page. Okay, where we will learn about supply air throttling and exhaust air throttling, which are the two methods of flow control. Now we will first understand what is supply air throttling. Okay, basically it controls the air going in the cylinder. In other words, it means that the supply line is throttled and the exhaust line is free flow. So what do we exactly mean by supply line is throttled and exhaust line is free flow? Supply line means air going into the cylinder and exhaust line means air coming out of the cylinder. So let's see how we are going to apply this concept to the following examples. So before we do that, okay, just to recap about flow control valve. The flow control valve is made out of two parts. One part is the throttled part, which is represented by this arrow over here, you can see, and the other one is the check valve, okay, whereby it either blocks or allows free flow of air going in. Okay, so let's take a look. So we shall understand what is supply air throttling for single acting cylinder first. So this is single acting cylinder. It has one air port and it has a spring here. So you can take a look at these two diagrams first, and you can realize that this one shows you the extension and the retraction process. This one is the representation diagram. Okay, so let's draw how extension process will look like. So during extension process first, the solenoid one will be energized, okay, so that the box will be switched to this one, which is nearest to the solenoid, okay, and the cylinder is extending. So the air will have to come in from this air port into the cylinder to push the cylinder out, which makes it extend. So this is the supply line because air is going in via this air port during extension. And then now I will draw the flow control valve, okay, and this is the throttled path. So supply air throttling means you have to throttle the supply line. Okay, in order for air to flow through this path, I need to make sure that the check valve is being blocked. Okay, so let's draw this way and let's analyze. I will draw the direction of my airflow in green. So you can see that the air is flowing in through the DCV to the flow control valve. I'll go to the check valve to check first. I can understand that it's being blocked because of the direction of my check valve, and then all the air will then flow through this throttled path, which means that I can actually regulate the amount of air going into the cylinder. So I will say that the supply line is now being throttled. Okay, so this is supply air throttling during extension process. How about retraction process? Okay, let's take a look. During retraction, okay, first of all, the solenoid is being de-energized. Okay, means no more power. So you go back to the spring position, which means the box closest to the spring, which is this. So during retraction process, the air will come out from the cylinder, and this is called exhaust line. Okay, coming out of the cylinder is called exhaust line. And then I will draw the flow control valve here. Okay, and then how would my check valve orientation be like? Okay, the check valve will be allowing free flow of air, because if you read the question, it says retraction without throttling means free flow. Okay, without throttling means free flow. So let's look at the direction of the air, which I'm going to draw in green. So the air is coming out of the cylinder, go to the check valve, check. Okay, it will allow all the air to flow through freely. Okay, so exhaust line is free flow. So it's retraction without throttling. And if I combine both diagrams together, it will be this way. Okay, some of y'all may start to ask, okay, can I draw the check valve to be on the right of the flow control valve? Okay, the answer is actually it doesn't matter, because we are only interested in the orientation of the check valve. Okay, so you can draw the check valve to be either on the left or on the right is okay. Most importantly is the direction of the check valve. Okay, so this is the final representation diagram. Next, we will go through supply air throttling for double acting cylinder. Okay, again, these two diagrams over here shows the extension and the retraction process, and this is the representation diagram. Okay, so let's do the extension process first. Okay, so during the extension process, air will go in from left, come out from the right in order to make the cylinder extend. I will say that this is the supply line and this is the exhaust line, because you can see from the direction of the air going in and coming out from the cylinder. Okay, so I need to throttle the extension using supply air throttling. Okay, so let's draw the throttle line first. Okay, so in order to throttle this supply line, I need to make sure my check valve is blocking the airflow. Okay, let's analyze using my green color pen. So the air is actually coming from this air supply, okay, through the DCV to the flow control valve. Then it goes to the check valve to check, okay, is the air being blocked? Yes, it's being blocked. So it will go through this throttled line. So the supply line is being throttled. So now I'll look at the retraction path. Okay, for the retraction path, this is how the cylinder is going to retract. The air will come in from the right and comes out from the left. Okay, so air that goes in is called supply line. Air that comes out is called exhaust line. Okay, so during the retraction process, I need to throttle the supply line. Okay, so how do I draw the flow control valve? Okay, first you draw the throttle path first. Okay, and then how am I going to draw my check valve? Okay, I need to block the air, right? So that all the air will go through this throttled line. So in order for that to happen, I will connect my check valve this direction. Okay, let's analyze with the green pen again. So the air is here, okay, goes to the flow control valve, goes to the check valve, check, is it blocked? Yes, it's been blocked. So it will go through this throttled line. So you can see that the supply line is being throttled, okay? So combining these two diagrams together, I will get a diagram like this, okay? To throttle both the extension and the retraction process. Okay, draw nicer. Oops. Okay. So this is supply air throttling for double acting cylinder. Okay, just a recap of how this CV works. Okay, since we're at this page now, you can see that when you want it to be extending, right, you have to energize solenoid 1 so that the box will be on the left. If you want it to be retracting, you will want the solenoid 2 to be energized. Okay, and this is the final diagram. So let's take a look at the summary of supply air throttling and complete the check valve symbol below. Okay, this is the check valve, okay, and color the airflow path to show supply air throttling of the cylinder in the indicated direction. Okay, so I will draw in red for the direction of the air. Okay, so during extension, okay, is this right? So supply line and exhaust line. So how am I going to draw the check valve symbol? Okay, I will color in blue. So the air will come from the air supply through the DCV to the flow control valve. Okay, supply air throttling means I'm going to throttle the supply line. So the check valve must be blocking the supply line. So I will draw in this way. Can you see my check valve direction? Okay, so when the air comes in, it will be blocked. So air will go through this throttled path. And let's take a look at the exhaust line. So the air will be coming out from the exhaust line. Okay, I'm supposed to have free flow. So in order to have free flow, I need to ensure my check valve direction is this way. Okay, so that the air will flow through the FCV freely. Okay, so in this case, supply line is throttled and exhaust line is free flow. Okay, now let's take a look at the next example on the right. Okay, so I'm talking about retraction. So retraction, I'll draw the 3 arrow first. Okay, this is the supply line and this is the exhaust line. Okay, so I'll draw in blue. Okay, so when the cylinder is retracting, okay, the air will come in, go to the flow control valve. I'm supposed to throttle the supply line, so that means the check valves must be blocking the airflow. So you can see it's being blocked. Okay, so you go through this throttled path. So now the supply line is being throttled. How about the exhaust? Exhaust, okay, first the air is coming out from the cylinder during retraction. Okay, so it will go to the check valve, and for supply air throttling, right, I'm supposed to let exhaust line to be free flow. In other words, the check valve must allow the air to flow through, so it must be in this direction. Okay, the arrow must be like that for the check valve. So the air will flow through freely back to the exhaust. Okay, so the exhaust line now is free flow. Okay, so that's the end of supply air throttling. Okay, to summarize, basically it means throttle the supply line, let the exhaust line be free flow, okay, in the extension process and the retraction process. Okay, so next we will talk about exhaust air throttling. Okay, let me explain what is exhaust air throttling. Okay, so exhaust air throttling is controlling the air going out of the cylinder, which means supply line is free flow and the exhaust line is being throttled. Okay, so let's take a look at this example over here, exhaust air throttling for single acting cylinder. Okay, so these two diagrams here shows the extension and the retraction process, and this one is a representation diagram. So for the extension process, we are not going to have any throttling as indicated here. So let's take a look at this directional control valve. The solenoid is being energized, so this box is being activated because it's closer to this solenoid. So when this box is being activated, you can see the air is going to flow through the directional control valve into the cylinder to make it extend. So let me draw the extension process here. And the air is going to go in, so this is called the supply line. Okay, because air is going into the cylinder to make it extend. And next, I will draw the flow control valve. Okay, I will first draw this throttled flow first. And I know that I'm going to do extension without throttling. In other words, the air should not pass through this throttled flow. So I will have to draw my check valve here and ensure that the check valve allows free flow of air. So in order for that to happen, the check valve orientation must be in this way. Okay, let's take a look. So the air is coming in from the air supply through the DCV to the check valve first, and then you check. Okay, the air is able to flow through freely, okay, into the cylinder. So the supply line is actually free flow. Okay, because it never flows through the throttled path. Okay, it flows through the check valve. Okay, now let's take a look at this retraction process. Okay, first the directional control valve has been de-energized. I mean, no more power to the solenoid. Okay, so it goes back to spring position, which means that this box is being activated now. So you can see that during retraction, the cylinder will actually be in this direction, and then the air will flow out and into the exhaust. Okay, so how do I draw this? So during retraction, the air will actually flow out from the cylinder. Okay, air flow out. So this is exhaust line. Okay, flowing out is always called the exhaust line. Okay, so I will draw the flow control valve first. Okay, again, as I mentioned earlier, this arrow can face any direction because it doesn't matter. Okay, what matters most is the orientation of the check valve. Okay, because I want to have retraction with throttling, okay, and I'm doing exhaust air throttling. So exhaust air throttling means you need to throttle the exhaust line. So in order to throttle this exhaust line, my check valve needs to block the air, correct? Okay, so my check valve orientation will be this way. Okay, let's analyze the diagram with my green color pen showing the airflow direction. So the air is flowing out of the cylinder to the check valve. You can see that the air will be blocked by this check valve. So you'll go through this throttled path, and in this case, the exhaust line has been throttled. So this is exhaust air throttling for single acting cylinder during retraction process. So finally, in the representation diagram, I will just draw this flow control valve, and again, what matters most is the orientation of this check valve. Okay, whether it appears on the left or right hand side of this throttled path, it doesn't matter as long as the orientation of the check valve is correct. Okay, with we will touch on exhaust air throttling for double acting cylinder now. I will first look at the diagrams. Okay, as you can see, this is the process, extension and retraction. Okay, and this is the representation diagram. Okay, so let's take a look. During the extension process, first you must energize this solenoid, okay? And then I will draw the flow control valve. Okay, so during the extension process, okay, let me draw in red instead. Okay, so you can see you energize this solenoid, okay? The cylinder will extend. Air will have to go in from the left and comes out from the right. And going in is called supply line. Coming out is called exhaust line. Okay, and I will draw the flow control valve. Okay, so for exhaust air throttling, okay, I'm only going to throttle the exhaust line. Okay, so I will not draw here. Instead, I will have to draw at the exhaust line. Okay, so to throttle it, okay, my check valve must be connected this way. Okay, let's analyze. When the air comes out from the cylinder, goes to the check valve, check, okay, it's blocked, so it goes through this throttled line. So exhaust line is being throttled. Okay, next. Let's go and take a look at the retraction process. So for retraction, air must be coming from right, going out from left. So this is the exhaust line. Okay, this is the supply line. Okay, and you're going to throttle the, you're going to throttle the exhaust line, okay, because exhaust air throttling, okay, during the retraction process. So how are we going to draw? Okay, I'll draw the flow control valve in black, okay, and I need to throttle it, so I'll draw the check valve direction to be this way. Okay, let's analyze using a green pen. Okay, air coming out from the cylinder on the left, go to the check valve. Okay, it's been blocked, so we'll go past this throttled line. So the exhaust line is being throttled. Okay, so combining these two diagrams together, my final diagram will just be this way. Okay, in order to throttle the extension and retraction process using exhaust air throttling. Okay, so now let's look at this. Complete the check valve symbol below and color the air flow path to show the exhaust air throttling of the cylinder in the indicated direction. Okay, so let's analyze. So you can see that this one is talking about the extension process. Okay, so the air is coming from left, coming out from the right. Okay, so you can see that. Let's look. Okay, so when the air comes in from the left, okay, goes to the check valve, I'm supposed to throttle my exhaust line. That means the supply line is free flow. Okay, so how do I draw the check valve direction? Okay, so the check valve direction will be this way, because this is the supply line and it's supposed to be free flow. Okay, okay, so that's why my check valve is in this direction. Okay, so that the air will go through the check valve. Okay, okay, so let's take a look at the exhaust line. Okay, so during the exhaust line, okay, so this is the exhaust line. It's supposed to be throttled, correct? Okay, according to the definition of exhaust air throttling. So let me continue drawing. Okay, so air coming out from the right goes to a check valve, check. Okay, it needs to be throttled, so I need to block it. Okay, so to block it, the check valve must be in this direction, so the air will just flow through the throttled path. Okay, so this is for extension. Next, I'll go to retraction. For retraction, first again draw the 3 arrows. Okay, So this is the supply line because air going into the cylinder. Okay, this is the exhaust line, okay, because air coming out from the cylinder. Again, as mentioned previously, supply line must be free flow. So I will draw my check valve direction to be this way. Okay, let's analyze. So when the air comes in from the air supply to the flow control valve to the check valve first, let's check. Okay, the check valve will allow the air to flow through because it's oriented this way. Okay, and that's why supply line free flow. Okay, next, air coming out from the cylinder goes to the check valve. Okay, I need to block it. Okay, because air exhaust line must be throttled. So to block it, it must be in this way. So you can see that the air has no choice but to go through this throttled line. Okay, so the exhaust line is being throttled. Okay, so I hope you understand what is supply air throttling and what is exhaust air throttling. Okay, basically supply air throttling means you throttle the supply line. Exhaust air throttling means you throttle the exhaust line. Okay, next let's take a look at some applications of these two flow control methods. So now we will take a look at the application of throttle check valve, or we call it flow control valve or throttle relief valve. Okay, so there are two types of load that will affect the flow control method. Okay, one is a resistive load, another one is the runaway load. So let's take a look at the resistive load first. So what is a resistive load? Resistive load means load you can control. Okay, in other words, if you apply force to this load and you suddenly cut off the force, that means no more forces acting on the load will just stop. Okay, so this is a resistive load. So let's take a look at this example. I draw the load over here. Okay, so when the cylinder extends, the load will move to the right. So when the cylinder is fully extended, the load will just stay there. Okay, so you can see that the load will not move unless there's a force acting on it. Okay, so let's consider this example. Okay, so for resistive load, you can either apply supply air throttling or exhaust air throttling. Okay, so in this example, I'm going to draw supply air throttling. Okay, both methods are acceptable. So since I'm talking about extension, I'll draw the extension process first. So how does the air go in? Okay, the air will go in from the left and come out from the right. Okay, so this is the supply line and this is the exhaust line. Okay, so as I said, resistive load, you can either apply supply air throttling or exhaust air throttling. Okay, so in my example, I'm drawing supply air throttling. Okay, so if it's a supply air throttling and during the extension process, where should I place my flow control valve? Okay, I should place it at the supply line. Okay, so I need to draw the flow control valve. Okay, and you want to control, right? So the check valve must be blocking, right? So can I say that the check valve must be in this direction? So let's analyze. So the air will definitely comes from bottom, okay, which is the DCV, which is not drawn here, which is perfectly okay, because now I'm purely analyzing whether it is supply air throttling or exhaust air throttling, and I'm drawing supply air throttling in this example. So the air goes to the check valve to check is blocked, so it has no choice but to go through this throttled line. Okay, so the supply line is being throttled. So I'm drawing supply air throttling example on resistive load. Well, you can also try drawing exhaust air throttling on resistive load, okay, during extension or retraction, okay. The answers are acceptable for both. So this is resistive load. Next, I will look at runaway load. Okay, so what exactly is a runaway load? A runaway load means load that will still continue to move even though there's no forces acting on it. Okay, so let's take a look at this example over here. This is the load. Okay, so can you imagine that when you lower down this load, okay, this load will still continue to move even when you suddenly cut off the forces acting on it? The reason is because of gravity. The gravity will push this load downwards, hence it is a runaway load. Okay, so let's analyze during the lowering of the load. Okay, so the air will go in from the rod side, okay, so which is here, and it is actually a supply line because air going in is called supply line, right? And air coming out, it will come out from the bore side. Okay, so air coming out is called the exhaust line. Okay, so let's analyze in green how this is going to work. Okay, so you can see that the air supply is here. You go through the DCV to this flow control valve. Okay, so I will draw in green and then take a look. When it goes to the check valve, can you realize that the check valves will block the air? So it has no choice but to go through this throttled path. So I will say that the supply line is being throttled and they are using supply air throttling because the supply line is being throttled. Okay, so they are actually applying supply air throttling during the lowering of the load. Okay, and why is this incorrect? Okay, well, it's because when you are controlling the supply, right, you are actually controlling this pocket of air over here in this cylinder, which I'm going to highlight in red now. Okay, and can you visualize that this is not efficient in controlling this runaway load? When the load is moving downwards, you will not be able to stop the load from moving. So this is an incorrect throttling method. Okay, so since supply air throttling is an incorrect throttling method, so what is the correct throttling method for runaway load? Well, the answer is exhaust air throttling. So why is that so? So let's analyze this diagram. Okay, using this diagram, and again I will draw the lowering of the load. Okay, and how does the air go in and how does the air comes out? Okay, so air go in is called supply line and air comes out is called the exhaust line, right? Okay, so since I already mentioned that we're going to apply exhaust air throttling, so I need to draw the flow control valve at the exhaust side, okay, during the lowering of the load. Okay, and I need to make sure that I block it so that this exhaust line will be throttled. Okay, let's analyze in green. So air coming out from the cylinder, go to the check valve to check. Okay, it's being blocked, so you will pass through here, the throttled line. So the exhaust line is being throttled. Okay, so I'm applying exhaust air throttling. Okay, and why is this good? Okay, so can you imagine when I throttle the exhaust line, I'm actually controlling the pocket of air here at the bore side of the cylinder. So can you analyze that this is efficient in stopping the load from moving downwards? Okay, so exhaust air throttling is the method to be used for runaway load. Okay, so since I already complete exhaust air throttling when the load is being lowered, now I would like to also draw the flow control valve when the load is being raised. That means during the extension of the cylinder. So you just need to, let me draw in black. Okay, so you just need to draw another flow control valve over here. Okay, and again the direction is the same as the one below. So you can analyze yourself that this flow control valve, which I have drawn using my black pen, will control the load during extension, okay, using exhaust air throttling method. Because when the load is being raised, okay, this line is actually the exhaust line. Okay, and you can visualize that it is using exhaust air throttling. Okay, so let me take a look at the next example over here. Okay, take a look at this load. Okay, this cylinder with the load. Okay, when will it be a runaway load? Well, in this example, you can easily see that when the load is moving downwards, okay, it will be a runaway load. Why? Because even though there's no forces from the acting on the load, okay, the load will still continue to move downwards because of gravity. So how am I going to start off with? Okay, so first, to lower down this load, the cylinder is extending, correct? So air will have to come in here and come out from here. Okay, air will come in to the cylinder and come out from here. So I'm going to apply exhaust air throttling because I already said that runaway load is using exhaust air throttling. So I will draw in red, and I know this is the exhaust line. So I will draw the flow control valve over here, and I need to block it. Okay, why? It's because you can see over here, air coming out from the rod side. Okay, go to the check valve, check is blocked, then it will go through this. So the exhaust line will be throttled, so that I can do this exhaust air throttling, okay, on the load, sorry. Yeah. Okay, so lastly, let's take a look at this diagram over here. Okay, again, ask yourself, where is the load? Okay, the load is here. Okay, so the load is a runaway load when it is moving downwards, which means that the cylinder needs to extend in this case. So the air will have to come in from here and come out from here to make it extend. Can you visualize that? So this is supply line, and this is exhaust line. Okay, and again, I need to apply exhaust air throttling on runaway load. Okay, so I will draw the throttled path first. Okay, sorry. Okay, and then the check valve must be blocking it. Okay, so let's analyze the diagram. So the air will be coming out from the rod side of the cylinder, right? Go to the check valve to check, is it blocked? Yes, it's being blocked. So you go through this throttled path. So the exhaust line is being throttled. That is why it's called exhaust air throttling. Okay, so with this, you can understand that, I hope you understand that resistive load, you can use supply air or exhaust air throttling, and runaway load, you can only use exhaust air throttling method. Okay, so now I will do a summary table to compare the difference between the two flow control methods. For supply air throttling, you can use on resistive load only. Okay, for exhaust air throttling, you can use on resistive load as well. And at the same time, you can also use on runaway load. Okay. Okay. Supply air throttling, you can also use on wide range of cylinders. Okay. However, for exhaust air throttling, you cannot use on small cylinders. Okay. Why? With this, we are going to look at how we are going to apply the flow control method on the different type of load using the following examples over here. Okay, let's take a look at example 1. Figure 1 shows a pneumatic cylinder circuit. Okay, this is the one. Which valve is controlling the retraction speed? Okay, since they asked us about retraction, the first thing I will draw is the retraction process. Okay, then I can visualize how the air flows into the cylinder and how the air comes out from the cylinder. Okay, so take a look at this. The air will flow in from the rod side and come out from the ball side. Okay, so let's analyze using a green pen. Okay, so to analyze this, I do not need to care about this directional control valve. In fact, I just need to focus on the flow control valve and the cylinder. Okay, why? Because if I want to analyze extension or retraction process, I need to keep switching this directional control valve, right? Sometimes using this box, sometimes using this box. So it doesn't really matter. All I need to do is I just analyze the flow control valve and the cylinder. Okay, so let's go back to the question. Which valve, A or B, is controlling the retraction speed? Okay, so when doing retraction, the air must come in from the rod side. Okay, so let's take a look. Air coming in from here, go to the check valve, check. Is it blocked? No, it's not blocked. Okay, in fact, it allowed free flow. Okay, next, I will go to this portion here to check. Okay, so air will come out from the ball side, go to the check valve and check. Is it blocked? Yes, it's being blocked. So this line is being throttled. Okay, coming out is an exhaust line. So I will say that the exhaust line is being throttled now. Okay, and going in is the supply line. Okay, so during the retraction process, A is controlling the retraction speed. Okay, and name the flow control method used. Well, as you can see, during the retraction process, this line over here is the exhaust line and it's being throttled. So what type of throttling method it is? It is the exhaust air throttling. Okay, and they ask us, state one suitable type of load condition for this type of flow control method to be used. Okay, exhaust air throttling is best for runaway load. Okay, in fact, it can also be used for resistive load. However, runaway load is unique to exhaust air throttling. That's why I write runaway load over here. Okay, so next I will go to example 2. So in example 2, name and state the function of component A as shown in figure 2A. Okay, it asks us to name and state the function. Okay, component A is a flow control valve, or you can call it a throttle check valve or throttle relief valve, up to you. Okay, so I will say that for part A, right, the answer is flow control valve or throttle check valve or throttle relief valve. Okay, I'll leave it for you to write. State the function of component A. Well, the function is to what? Control the speed of the cylinder. Okay, so the function is to control the speed of the cylinder, because you're actually regulating the amount of air going in, right? So by regulating the amount of air going in, you're actually controlling the speed of the cylinder. Okay, next. State the changes that happen to the cylinder when component A is being reversed as shown in figure 2B. Okay, so let's take a look at this two diagram. What's the difference? Well, the difference is in the check valve orientation. Okay, so maybe I want to analyze figure 2A first. When will this flow control valve be controlling the cylinder? Is it during extension or during retraction? Okay, looking at the orientation of the check valve, I can see that it will block when air is coming in here, right? So I will say that you are actually controlling it during the extension process. Okay, how about this diagram over here? Okay, let's analyze again. The check valve is being blocked when air is coming down from here, correct? So coming down means it's coming down, so it must be like that, right? Okay, so can you see the difference now? How A is affecting the extension speed in figure 2A, and it is affecting the retraction speed in figure 2B. So you can easily write this down over here, that for part B, you can just state that in figure 2A, A is controlling the extension speed of the cylinder. Okay, and in figure 2b, A is controlling the retraction speed of the cylinder. Okay, so with this, we will go to the last example over here. Figure 3a shows a schematic layout of a pneumatic cylinder that handles a 50 kg load in a packaging line. So you can see this is the load. Okay, you're trying to lower down this load. Okay, a flow control valve is to be incorporated with the intent to control only the extension speed or the lowering speed. Okay, so that means the cylinder has to extend to lower this load. So explain why the speed regulation shown in the pneumatic circuit of figure 3b. Okay, this is figure 3b. Why is it wrong? Okay, so let's take a look. So first, this is the load, and we're going to lower this load. So how does the air go into a cylinder, and how does the air come out? So the air will go in from the ball side and comes out from the piston side. Okay, so going in is called supply line, and coming out is called exhaust line. Okay, so next, let's analyze in green how the air is coming out. Okay, that because the flow control valve is here, so we'll analyze the air coming out from the rod side. Okay, so go to the check valve to check, is it blocked? No, it's not. It allows free flow of air. So exhaust line is actually now free flow. So the questions ask us to explain, right? Explain why the speed regulation is wrong. Okay, so you can say that when lowering the load, the flow control valve, which I'll write in short form, is not regulating or controlling, okay, the speed of the cylinder, okay, because it allows free flow of air. Okay, so next, draw the symbol of one flow control valve in its correct orientation in the space at A or B. Okay, so I can draw in A or B to regulate this extension speed. Okay, so now this time around I'm going to use my red pen. So extension speed is this way, air goes from here, comes out from here. Again, this is the supply line, because air goes into a cylinder is called supply. Air coming out will be exhaust line. Okay, so you want to control this extension speed. Okay, and you know that what type of load is this? This one is a runaway load, because you can see that when you lower down this load, if you suddenly have no forces acting on this load, it will still continue to move down because of gravitational force. So since it's a runaway load, I need to use exhaust air throttling. Okay, so I'll draw over here. Okay, and I need to make sure the check valve will block it. Okay, so let's analyze in green. Okay, so air coming out, go to the check valve, block. Is it blocked? Yes, it is. So it will go through this throttled path. So the exhaust line is now being throttled. Okay, so lastly, state if the type of throttling method used is supply or exhaust. Well, the answer is obviously exhaust air throttling. Okay, so we have come to the end of example 3. Okay, next, you can see that we also have other type of actuators, okay, which are the output elements. Remember, the control chain have input element, signal processing element, final control element, and output element. Cylinder is also one of the output element. Okay, for electrical drive, right, DC motor is also a output element. So how do we draw motor? Okay, so to simplify things here, our symbol for motor is just this. We just write a coil with a M to represent motor. Okay. And what are the applications of motor? You can be used for index table, printing, and conveyance. Okay. Next, another type of output element is what we call linear solenoid. Okay, so what's the symbol for linear solenoid? It's just this. Okay, and always label your symbol. Okay, so I will just call it solenoid, SOL. Okay, and you can read for yourself what the typical applications for linear solenoid. Okay, one very commonly used is actually electronically activated door locks. Okay, and lastly, motor contactors. Okay, it's used to drive motor, right? So that's why motor contactor is a final control element. Okay, so how do you draw the coil of the motor contactor? Okay, normally motor contactor we call it we give it a name. Maybe the symbol can be MC or MR. Okay, we either call it motor relay or motor contactor. So in this case, I'll just write MR. Okay, it's just a name, so it's okay. And in a motor contactor, they have a normally open contact and a normally closed. So this is how we draw: normally open. Okay, and of course you must label also because it's part of the motor contactor, and normally closed. This is how you draw. We will further elaborate on how this works in the next lesson, okay, in EP3. So these symbols you need to know because we are going to apply them later on. Okay, with this we will end our lesson for EP2.